participants. So hello and welcome to this year panel discussion of the SDEWES Conference. And the name of our panel discussion is Climate Neutrality in Cities. The reason why I was trying to organize such a panel is also a bit egoistic. The reason is that in my city here in Cologne in Germany, the city council has set up a climate board in order to look how even a city like Cologne can meet its climate targets. And the way is maybe not that easy like in the countryside. In the countryside, we see everywhere wind parks. We have a lot of roofs full of PV. But when I climb the Cologne Dome, for example, and look around Cologne, I almost see nothing renewable. And there's a long way such cities have to go. And therefore, it is egoistic that I have called this panel because I hope that I can learn a lot from the panelists here. And I don't want to make a lot of words. I just would like shortly to introduce our panelists. I try to do that in alphabetic order of their first names. And that is the reason why I start with Brian Mathiesen. He is a long year member of the International Scientific Committee of SDEWES Conference. And he is from Aalborg University in Denmark. And you just have seen him in his invited lecture. I hope he still has the power to also pass here a 2 hours panel. And you're free, I think, also to eat during here the panel we have here. Then I'm very happy that we could gain for the panel Jonas Tolf from Stockholm Stad in Sweden. And I think Stockholm is maybe together with some other Scandinavian cities, one of the leading who are going forward in towards the climate neutrality. Then we have Monica Salvia from National Research Council of Italy. She's also participating here in the conference. And then we have Peter Droege. Peter Droege is from Liechtenstein Institute for Strategic Development, but I know him better as president from Eurosolar, and together we already have organized several international renewable energy storage conferences. And I invited him because he is author of the book Urban Energy Transition. And therefore, I also hope a good input from his side. Then we come to Rodney Stewart. Rodney Stewart is a new member in the International Scientific Committee here in SDEWES, but also a long year participant here in our conferences. And he is from Griffith University at the Gold Coast, where we had just 2 conferences ago, also a pure online SDEWES conference. And welcome, Rodney. Then I think you also know Şiir, you know, where do I have Şiir KILKIŞ? She is from the Scientific and Technological Research Council of Turkey in Ankara. And I think you know her very well. She's also a long year member of International Scientific Committee of SDEWES and just had introduced and organizing the invited talk of Brian. And then last but not least, we have Takaaki Furubayashi. I hope I pronounced the name almost correct. And he is from Akita University in Japan. And I also would like to congratulate him. He just 2 days ago became father of his 2nd child. And I think as he is lacking his wife at the moment, he has his 1st child together with him. So we try to be here flexible whenever he has a need to pass away to care about his child. We will order our speeches in a different way. But now I stop talking. And I would like to ask now in the vice versa order to give you introductory notes, and then I would like to ask Takaaki first to start with his introduction. You need to unmute your micro. Yeah.
Thank you very much for your introduction, including me and my first child. Okay. How do I start? Okay, I'm an energy system researcher in Japan. And excuse me, can I show the presentation file or something?
You have to share it. Share the screen.
Yeah. With the green button in the lower part, you have the ability to share your screen.
Okay.
Yes, great. Now we can see.
Yeah. Excuse me. Okay, now I show you the characteristics of energy system in Japan's urban area. Okay, here is the conventional energy system. Sorry. Resource conversion resource conversion technology and demand. And each component, resource to conversion to demand, there are something, the transportation, resource transportation, or energy carrier transportation, grid electricity connection, or district heating. So what are the barriers and solutions to increase the share of renewable energies in urban area? Resource, conversion, demand, infrastructure, policy, economy, and assets. Here is the final energy consumption in each 47 prefectures in Japan. Excuse me. Here is pointer. Tokyo is here, and my city, Akita, is here. So I'm not urban area research. I'm from rural area in Japan. But you can see the Tokyo and around the Tokyo area, Kanagawa, Saitama, has huge final energy consumption. So here is the final energy consumption in Tokyo. It's more than 800 petajoule per year. And the commercial is the largest. Half of them are electricity, but still oil and natural gas. I skip the Osaka's. And potential of offshore wind and solar power in each prefecture. The Tokyo has larger solar power, but it's still much smaller than the demand, because maximum is 44 petajoule in each prefecture. And also, and wind, north area has huge potential, but Tokyo not. So to cover the Tokyo's final energy consumption, we need to use the wind power in north area. But there are some restrictions, some constraints. For example, the grid connection between regions, the Tohoku and Hokkaido, where has huge wind power, but the connection is only 12.6 gigawatts to Tokyo. And here is the supply area of city gas. Colored area has city gas, and the red line shows the main city gas pipeline. You can see the north area to Tokyo area, there are no pipeline. So solution pathways and barriers for climate neutrality in Japan's urban area. Much smaller renewable energy potential compared with demand. So we need to import from other area. The low grid connection capacity between regions. So increase the capacity or power to X and import X. The short gas pipeline, the extend gas pipeline to import the methane or hydrogen, or transports X by truck, train, or ship. So no district heating system. So install district heating or electrification heat pump or individual biomass boiler installed. So economic and policy is of course important, but in Japan's urban area, infrastructure is very cheap. So we need how to design the urban areas energy system at first in Japan. Sorry, my child interrupts sometimes.
So thank you very much, Takaaki. I know you have hard conditions to participate here, but thank you very much. What I forgot in my introduction, when you have questions, please use the Q&A part you also find in the lower bar of the Zoom taskbar. And when you have asked your question there, please also raise your blue hands that later Felix, our technical manager here, is much more easier can find you to unmute you, that you can talk then in person and I not to read your questions. But now then I would like to pass over to Şiir with her introduction.
Thank you very much, Ingo, for this excellent panel of bringing us all together. And in the panel introduction, yes. As initial statements for the panel, I would like to emphasize the integrated approach in urban areas with correct timing and response. And we know that tipping points can be exceeded even in 1.5 and 2 degree scenarios while emission gaps remain. And can urban areas continue to realize the transition for climate neutrality? And can they accelerate the transition for climate neutrality? These are the main contributions that I would like to initially make for the panel. And if we look at the urban areas in Europe, in 2020, urban areas will be responsible for about 4.17 gigatons CO2 this year. And this needs to be reduced to at most 2.25 gigatons CO2 in 2030 and about 0.75 gigaton in 2040. And we can say that while the pioneering cities will reach climate neutrality much earlier, we also know that we need to reach climate neutrality for all urban areas in the year 2050. And in this pathway, while urban emissions from Europe will be about 16% of the total world urban emissions this year, the share will be continuously reduced on the path to climate neutrality. These values are based on the scenario framework of one of the shared socioeconomic pathways. The first one, or SSP1, under a radiative forcing level of 1.9 watt per meter squared based on the image model, together with original analyses based on local emissions data. SSP1 has higher renewable energy penetration and decoupling from the baseline scenario onward. But even these values can be improved with faster penetration of renewables in earlier years to reduce the need for negative emissions in later years, leading to the year 2100. From an urban perspective, what needs to be done is to increase the number of climate neutral cities at much earlier years, even beyond the Horizon Europe mission target of 100 climate neutral cities by 2030, and utilize all opportunities to allow urban areas to support energy system integration for the renewable energy transition. The recent EU strategy also emphasized the importance of exploiting synergies across sectors, renewable energy-based electrification, and low-temperature district heating systems. All of these represent a good fit with the opportunities that are available in urban areas. The SDEWES Index has also been developed to benchmark the performance of cities with 7 dimensions in support of urban system transitions, and also represents the strategy of improving performances based on renewable energy penetration across urban sectors, considering urban planning, and decoupling emissions from greater well-being. Especially the pioneering cities from the results of 120 cities are the most suitable to reach climate neutrality first. At the same time, progress in all cities are important to accelerate urban transitions and the reductions that are needed across urban areas as a whole. Pioneering cities are also represented in this panel today. We need to see the entire urban system as part of the solution for energy system integration, including climate neutrality for all urban sectors through multiple strategies. Progress towards fourth generation district heating and cooling networks, the use of waste heat, improvements in flexibility across urban infrastructure, including energy and water storage, increase in electrification, better urban form, and wiser resource efficiency with water and waste management are all urban needs and opportunities. What we need is for urban areas to capture opportunities for integration across energy, water, and environment systems that also forms the basis of this research community. What if the top 10 pioneering cities realize climate neutrality by 2030 or even some at 2025? These cities would further improve their performances based on the SDEWES Index, with improvements in related indicators, including 100% renewable electricity, the lowest particulate matter 10 concentrations, low ecological footprint, and better urban planning. The pioneering cities of the SDEWES Index and their collaboration can also be an important part of the climate neutrality solution by 2030 and its rapid spread to other cities, since much more action is necessary to realize the urban system transition. And let us think of all the urban areas across the world, including those still emerging or will be emerging. There's also urban areas in the rest of the world to come to climate neutrality with a similar time frame at mid-century, again, based on the SSP1 framework. The rapid action that we need for renewables to have 100% renewable energy scenario by 2050 will clearly need to be supported with urban areas as part of the solution. Beyond only urban areas, here we see the representation of 100% renewable energy scenarios for 2020, 2030, 2040, and 2050 worldwide. These and similar scenarios provide the context in which urban areas need to use their advantages to support a faster transition. And as we will be discussing in the panel today, there are many cities that have adopted renewable energy targets across the world, from Europe to Southeast Asia, as well as Sub-Saharan Africa. I would like to conclude this initial panel statement by encouraging researchers and policymakers to work together in critical and urgent times for the correct timing and response for climate neutrality. Thank you.
Thank you very much, Şiir, for your introductory notes. And then we go to Australia and switch to Rodney.
Thank you, Ingo. I don't have a presentation today. I just wanted to make a few statements to sort of add to what Şiir has mentioned about towards the end of her presentation about the integrated planning. And I wanted to emphasize today the importance as we transition towards climate neutrality in cities, that we need to think about sustainable urbanization as part of that. So the connectivity between the water, energy, food is an important driver, because climate change is affecting water supply, which has a major effect on our energy planning. So hydropower is obviously linked to water availability. A lot of energy generation requires extensive water use for cooling. So I just really wanted to emphasize today about that integrated resource planning and the importance as governments and as researchers that we promote having our energy planning also have a strong consideration for the water system. So really about that integration of that water and energy planning, and reap the benefits that we can get from, say, wastewater treatment plants and biogases from that for, you know, district heating and cooling, but also in terms of, say, using renewable energy generation to heat water, you know, in excess times and things like that, which are, you know, by looking at that integration and thinking about how we can plan water and energy together, we'll come up with a whole different portfolio of solutions to if we did energy planning separately from water planning. And I think from a cost economic perspective and from a more sensible greenhouse gas emission saving perspective, I think if we did that planning, I think we would get better solutions. And also we should be thinking about, as Şiir also mentioned in her second last slide there, about that sort of that sustainable urbanization as well, because that's a key feature. We need to plan our cities considering sort of local harvesting of water and energy. So we, you know, and also, you know, local urban agriculture. So we're not transporting water and energy to great distances. And I think if we have that planning lined up and we use those green building, green design sort of features in our cities, where possible. That's not always possible in older cities, I can understand, but where we can do that, where it's possible, I think that we can, you know, come up with better solutions overall. So I just really wanted to make that short statement tonight, Ingo, and hand over to the next presenter.
Thank you, Rodney. And then we continue with Peter.
Thank you, Ingo. This is a wonderful kaleidoscope of technologies and speakers and capabilities that are collected in this conference. And they all have to be brought to bear to achieve a full climate negativity, not neutrality, because that's a goal that's already behind us. We are 20 years too late to try to aim at climate neutrality. And my presentation is about the fact that it's time to leave that behind and to realize that calling for climate neutrality is actually slowing progress. The cities that Şiir spoke about, the leading cities, they have to aim at negative climate performance because the West is so far behind. If they aim at climate neutrality, we'll all be much too slow. And the reason for that is that this 1.5 degree target we aimed at is far too high. Already at 0.8 degrees Celsius, the Arctic started to melt. We all know what that means. The polar vortex began to be destabilized to stratospheric heat waves. These heat waves destabilize the Arctic cold pocket and create this crazy weather pattern we see now. That means we have a destabilized jet stream around the world, and that means the Rossby wave, gravity waves of air movements, creating a global heat problem, which is jeopardizing in a very near term global food production. It also means that the Bolsonaro effect is not really helping, because the burning of South America, but also Africa and other continents, means that there's an enormous carbon dioxide emission, where not already bad enough to see the biodiversity depleted and the weather pattern for the South American continent. Here you see the carbon monoxide plumes emanating from the burning rainforest last year in South America, and to the right you see the burning forests of Africa. And to the north you see the burning Arctic boreal forests, the Siberian forests, also emitting carbon monoxide and of course carbon dioxide and methane. That means we are in a very much in a tipping point as we speak. We are beyond the tipping point. We have to realize that and begin to cope and deal with it. It means that the 280 parts per million in CO2 that the Earth, the biosphere, was peaking at for the last 800,000 years is reaching this month 415 parts per million. It's 150% above the stable level. We're way above the stable level. In CH4 and methane, we were 600 parts per billion for the same time period. And we are 300% above that this month in methane, in atmospheric methane. Well, what does that mean to temperature? 1869, which is generally regarded as pre-industrial, it's not really pre-industrial because pre-industrial meant a century earlier. The average temperature was 13.7 degrees. Today it's almost 15 degrees. Now these 15 degrees are a little misleading because 99%, 95% of the absorbed energy is being absorbed in oceans. Were it not for the oceans, we would have 65 degrees Celsius right now. Now the question now is where do we head? If we don't find a radical way of reversing course, we're heading towards 250 degrees, as been already predicted by Stephen Hawking and Carl Sagan, two astrophysicists who mapped a worst case scenario. And the worst case scenario is really explained by the proximity of the Earth to the Sun. Venus is much closer and it's got 460 degrees, so that's a little more balmy for our planet. Now, you see the temperature kicking up for Germany already. We are 2.5 degrees, not 1.2 degrees, 2.5 degrees above pre-industrial levels in Germany. And much of that rise was in the last 20 years. And to the right, you see the red line kicking up in an exponential manner. It means really that if we were to take the carbon budget of 2014 series, the 420 gigatons of CO2, we would have to begin this year to reduce emissions by 18 degrees each year to reach that 1.5 degree maximum level of temperature increase. Now the 420 gigatons, of course, are already too much as I described. So the chance of reaching 1.5 degrees is only 66% if we were to start reducing 18% each year. Had we done that in the year 2020, here we would have gotten away with 4% reduction, but we didn't do anything. We kept emitting. And that means we have got a double problem. Not only are we not able to meet that carbon budget, we're also realizing that the carbon budget doesn't exist anymore. So the target is not above us, the target is below us. It's got to be 280 parts per million. That means it's got to be not 1.5 degrees, it has to be 0 degrees, the stable level that we knew existed before. In some way, somebody has created a maximum possible worst case scenario of 1.5 or 2 degrees as a target. It's not a target, the target is below us. That means the action horizon is not 2050, it is now. It can't possibly be 2050 because it's far too late, and it's also running against human nature, which doesn't start acting until it's 2049. The emissions reductions can't be 100%, it has to be 150%. We have to reduce more emissions. We need to absorb more emissions than we emit. That means we've got to create 100% environments, and because of the fact that most of the built environment is already built, we have to produce 100% performance plus, meaning those areas, those cities, those districts, those buildings that produce 100% renewable have to actually compensate for the environment, for the surroundings, for the rest of the districts, and generate 200, 300, 400, 500, maybe 1,000% of their capacity to supply the rest of the city instantly. And that's what I meant by we need a solar virus, in the sense that the regulations have to demand not just barely self-consumption or self-demand being covered, but to produce for the environment that they're in, to compensate for the fact that we can't change the environment very rapidly. That means all these wonderful examples that we see in suburban areas which reach 100%, they need to, in fact, now be goaded very rapidly towards producing 200, 300, 400%. And you see the most of the roofs, and Ingo mentioned that before, are still completely empty. And now Werner Sobeck, a famous German architect, has done that with his 000 active house and demonstration in Stuttgart, where he supplied the surroundings with excess solar energy, including the Le Corbusier Museum next to it. But it's a small exception. That's got to be common practice for all new buildings. It's got to be all common practice for all new urban development areas that not just produce their own energy consumption thermally and electricity wise, but for the wider surroundings as well. And it is also the same demand that we have now for buildings in the city. Now that's a surplus building, a big building in Frankfurt that does produce more than it consumes. And so applause to that. That's the future. That's the future in the Philippines. That's the future in California. And by the way, it pays. It can be financed through urban city finances. The study in the book that I edited that Ingo referred to by John Byrne shows that major cities around the world, Amsterdam, London, Paris, New York, Seoul, Tokyo, can, through their own bond issues, within 10 years achieve the maximum capacity of their solar potential, just by rooftop solar. We also know from the Rocky Mountain Institute that districts can finance their own net zero energy focus. That means they can, in fact, issue financial instruments to the urban administrations that allow them to invest into solar, which then regains that as compensation, profit and savings in the future. And so these new districts are look like normal districts, but they supply their own solar power and they're traded among themselves. This is a peer-to-peer trading, solar trading for 100% examples from Australia, Whitecomb Valley in the Perth area. In Zurich, we've got a similar project, which is also surplus energy producing. Kalkbreit in Zurich, it's a cooperative, which also has minimum floor area for the occupants. People share rooms and spaces they don't need and rent them from the collective. It's built above a tram station, so there's perfect transport access. And if you drink too much coffee, you miss the tram, take the next one. It also helps through its design to liven up a neighborhood, which is a bit dull at times, but it is also connected to Autoloco and other food cooperatives. That means the people that live there also rent, lease, or own agricultural plots near the city. And that's also part of the rapid change. We have to have the food supply, the resilience that's required to survive the coming decades. Now we've got historical monuments in Germany and in Berlin. This is something that's been built in the 1990s. The entire government district of Berlin is renewable. It's self-sufficient. It uses the electric grid as a backup, as its own thermal storage systems deep underneath in geothermal in caverns. So that's an extraordinary example that few people are realizing that is possible, and it can be achieved in a way that supplies the surrounding areas, these ministries and office buildings and the parliament itself. And so there we are. We can also generate, just through the important efficiency improvement, enormous employment and financial value. That's also demonstrated in the book that Ingo referred to. And finally, there is an open-air museum in Germany. And for those of you that are in fact physically watching, go to Hamburg. There's the International Building Exposition that's focused on the largest river island in Europe. And it's converted itself in 7 years to a renewable energy district. It's guided by an energy atlas that I helped write or map. But it's really about describing scenarios of self-sufficiency in thermal and renewable and renewable electricity, using the capacity of the buildings and the built environment to do so, while increasing population to 150% of the current level. So
Peter, how many slides do you have left?
Yeah, that's right. I'm almost done. There's 2030 we'll have 100% electricity, and so by 2050 85% thermal energy. We have done zero emissions, and from there on negative emissions. So there are many projects you can go and visit. They're also online, and I hope you will be inspired by them. There's also a wonderful biogas powered heating and electricity network for the neighborhoods. And there's a World War II former Nazi air defense bunker that's been converted into a heat storage facility where you can drink your coffee and survey the surrounding renewable energy landscape. And so maybe I should just end with here and just, am I over time? Ingo?
Slightly, yes.
Slightly? Okay. Zooming through it, there's regions after regions in Europe that people usually don't know about, which have achieved this 100% and are able to, in fact, supply income, investment opportunities through renewables. And we finally, and this is the end of it, Ingo, thank you for the patience. We've got a mapping tool developed which enables regions and cities to map their own renewable energy potential, but also the 100% potential and the CO2 emissions negative potential that can be reached by also doing the right soils management, forest management, and wetland management. In this case study in the Lake Constance region, 115,000 square kilometers in the southern part of Germany, between Switzerland, Austria, and Liechtenstein, can show that 2050 we can have a negative carbon balance, and do what we have to do is absorb CO2 from the atmosphere, and that's the target for 2050 you have to aim at, not carbon neutrality. So that includes the soils, includes converting your soil cover and the agriculture, and reading this book. That's a fantastic book which I can only recommend. And finally, go to eurosolar.org and help us spread the word by becoming a member. It's only 60 euros a year, and I'm allowed this little commercial because Ingo is one of our best and longest standing members himself. Thank you very much.
Okay, thank you very much, Peter. And in order that we also have time later to discuss, I directly would like to ask Monica for her introductory notes.
Yes, just 1 second. Okay. Okay. So, can you see my screen?
Yes, perfect.
Okay, perfect. Just 1 moment. Okay, so good afternoon, ladies and gentlemen, and let me start saying thank you to Ingo Stadler, the chair of this session, for inviting me to contribute. In this small, very short statement at the beginning of this panel, I would like to bring to the table the results of a very recent study we have just published with a very nice group of researchers coming from all over Europe, and because I think that it will it could bring some food for thoughts during the discussion. The study, the aim of our research was to investigate on the ambitions of European cities in terms of climate mitigation goals included in their mitigation local climate plans. And so we analyzed the type of plans and the targets, the mitigation targets, and the relations with the city size, the combination of adaptation and mitigation aspects in a single strategy, also in relation to the membership of climate networks. So the main objective was to identify whether the ambitions was enough to reach the Paris Agreement. I will provide just few information about the methods we used. This is a graphical representation of the city sample. We took into account 28 countries because at the time of the analysis, UK was still in Europe, and we analyzed the local climate plans of 327 core cities in Europe. The sample was provided referring to the urban audit database from Eurostat, which represent a representative sample in terms of size and in terms of regional distribution of cities per country. And the main step of the research were the following ones. First, we searched the mitigation local climate plans and we organized them in a database. Then we classified these plans according to a common typology, which is represented in these in full colors in this paper. We follow the method already used in previous publications led by my colleague Diana Requien from University of Twente. So we distinguished between comprehensive and standalone plans, mainstreamed plans, and plans dealing with, for example, energy plans dealing with mitigation targets. And we then carried out a content analysis of one plan per each cities using the key information represented in this table, and we carried out a statistical analysis to investigate the relationship between mitigation targets and the urban population, climate membership, and types of plan and integration level. What we found is that 78% of the cities in our sample have a mitigation plan, of which 61% of them include targets in terms of CO2 emissions, and the remaining 39% in terms of CO2 equivalent emissions. I will move straight to the carbon neutrality results. Here I represent an overview of cities in our sample striving for carbon neutrality. We found that 25% of the cities in our sample, which means 81 cities in Europe, are striving for carbon neutrality, while 73% of them strive for carbon neutrality by 2050, and on average by 2045. I would like to point out the case of the city, the Swedish cities of Malmö, which aims to become carbon neutral by 2020. And about where in Europe, while Germany is for sure at the forefront, because I mean we had that about 1/3 of the cities in our sample declare a carbon neutrality target, and it's followed by UK, Netherlands, and France. But we need to point out the really good example of Danish cities, because all the 4 cities in our sample strive for carbon neutrality. And regarding the size, the influence of city size, we can see that 60% of cities with a size going from 100,000 to 500,000 inhabitants have a carbon neutral target. So size seems to be also a very important predictor for carbon neutrality. And in this representation, we put on the x-axis the 81 carbon neutral cities in our sample, and on the y-axis the population. And we have bars with different colors representing the different typologies of plants, and we can see that 74% of the 81 carbon neutrality striving cities have a comprehensive plan, mitigation plans, autonomously developed, and that about 10% of plants have an A3 plans, which is a plan developed within a climate alliance, and only 5% have an energy plans with the mitigation targets. And regarding the influence of climate alliance, we can see that 75%, which means 3/4 of the analyzed cities are members of the Covenant of Mayors, which seems to be the most influent climate network in our sample, followed by the Climate Alliance, 35%, C40 Alliance, and about 7% are members of the Carbon Neutral Cities Alliance. Moreover, we also found out that about 25% of cities are members of 2 climate networks, and about 5% of our cities are members of 3 climate networks. So, a list of the key results. 78 of cities have a mitigation plan with targets, and the average reduction targets is around 47%. Only 25 cities in our samples strive for carbon neutrality, most of them by 2050, with an average by 2045. And 90% of cities striving for carbon neutrality are members of the Climate Network, among the 4 analyzed in this study. And ambition seems to be driven by city size, the adhesion to climate networks, the integration of mitigation and adaptation objectives in one plan, and also local motivations, which means the typology of plans for a specific city. And regarding the geographical patterns, we saw that the most ambitious cities are in Northern and Western Europe, and that we can observe a sort of a Mediterranean pattern in which the share of cities aiming for carbon neutrality is quite low and ranges from 0 in the Eastern Mediterranean country to 22% in France, where local climate plans are compulsory by law. And because, I mean, and we also found out that European cities must double their ambitions if we want to meet the aims set by the Paris Agreement. And obviously further research is needed to evaluate different key aspects, and first of all to evaluate the effectiveness of the measures and actions included in the local climate plans analyzed. And just to mention that this study is part of a series of studies which we call the Euro LCP initiative. So I would invite you to read some of our papers in order to know more about our research, and I'm available for questions, comments, and everything you like. Thank you very much for your kind attention.
Thank you very much, Monica. And as we already spent 50 minutes, we continue directly with Manuel in South America.
Hi. Listening to me?
Hello, yes, you can start. We can see your slides, yes.
Yeah. Hello, my name is Manuel Ignacio Ayala Chauvin. I am a professor at the Universidad Tecnológica de America. I am from Ecuador. The topic I will explain is the evaluation of the energy autonomy of the urban areas as a tool to advance the renewable energy transition. Here is Ecuador, and here, Ecuador, and here is Galapagos. The case study is Loja, Ecuador. Is a city, a medium-sized city located on the zone of Ecuador here, and 600 kilometers is Quito capital. The case study. One reason why I carry out the research is because the wind farm is close to the city. Look, therefore, the generation of the wind farm directly covered the consumption of the city. The schematic shows the topographic situation. Loja is 2,100 meters, and the Villonaco wind farm is located at 700 meters. And Catamayo is other city, 1,000 meters. This topographic situation causes the hill effect occur because between Loja and Catamayo, there is a temperature diversion approximately 10 degrees Celsius. And this creates the wind flow in predominant direction towards the west. Now, the method. The method is first delimitate the study area and use these tools in order to analyze the consumption and generation. And the method is based on taking measurements of the consumption and the generation in order to determine the coverage percentage of the wind farm and with this result, propose improvements of the system management. Generation and consumption were contrasted and determined the surplus and deficit and deficit. In addition, climate periods were determined. This data allowed us to improve the energy management in all the periods. Now, the first part analyzes the electrical uses. This tool and disaggregate measurements were carried out for each user, obtaining and classification. You can see the, for example, you can see the residential consumptions. After this, analyze aggregate measurements were also made at the substation levels. For example, this city has 4 substations and take measurements in all the substations. This is one substation, substation north, and other substation covered this area, and other substation covered this area, and this is substation zone, covered this area. Take measurements and all the feeders, and you can see the aggregate consumption in the city, and you can see the all the consumption in the city. Now, with this information, you can determine the curve, the consumption curve, the demand curve, and analyze the possible strategies in order to flatten the consumption peak. And you can see statistical information on all the days of the week. And when this partial consumption, and you generate a reference map with this information using RStudio and QGIS, consumption classified in rates, residential, commercial, industrial, senior citizens, and efficient cooking. And you can, the consumption is visualized, and the big consumer are identified. And this is interesting in order to improve the management system. Now, the second part is the analysis, the power generation. Is interesting because it's near the city. You can analyze easy what's the percentage cover in the urban area. You can see this 5 years, the measurements of the wind farm, and you can see the seasons is characteristic. And this is the power generation, and determine the capacity factor is the 60%, and this is the production of the wind farm. This is the gaps when is in February and March gaps because you don't have any wind. And this is interesting information because I determine in 3 weather seasons in Loja. One rainy period is summer and autumn. This is one season. Cool dry period is winter, and one dry period is spring. This information is not evident if you don't analyze this information. Now, finally, you can to evaluate the autonomy of the city and determine with the service time. This is the complex part because when you analyze and real data and real time, you need contrasting, and after this you can standardize all the information and contrast it, the generation and consumption, and determine the surplus and determine the deficit in order to dimension saving systems. Finally, with this wind farm cover directly 62% of the consumption of the city. This part is amazing, and finally, the method is very flexible and can adapt it in territorial scale in order to it's an orderly user-free software and therefore is inexpensive and implement using an RStudio. The 3 climate periods were determined that will serve to the planet and prediction of the generation. The wind farm generation can directly supply 62% of the electricity needs of the urban areas. And now the wind farm doubling the capacity of the wind farm, and the result is 74% covered directly. And therefore, in addition, in order to improve the cover or autonomy of the city, increasing the capacity plant, and is necessary implemented energy saving and efficiency program. This is amazing because you have a city autonomy and with only one wind farm. The context is different because the city is not a high density city. You have a resource near the city. Thank you very much.
Thank you very much, Manuel. And then we come finally to our 2 participants from Scandinavia. And then we start with Jonas from the city of Stockholm.
Okay, just a minute. Now see. Share screen. Do you see the presentation now?
No, we don't.
You don't?
No. You tried the green button?
Oh, I hope so.
Okay.
Try it again. Ah, you have to click twice.
Now it's perfect.
Now it's better, isn't it?
Yep.
I have the full screen there.
Yep.
So, thank you for the invitation here and the very kind introduction. I will just give you a quick and short introduction to Stockholm's contribution to the Paris Agreement. The governing policy document for Stockholm's environmental work is the Environment Program. It focuses on 6 environmental areas where climate is, of course, one of them. And it is in the Environment Program that the targets are set and decided upon by the City Council. And in this program, all responsible bodies for the targets to reach the targets, that is the city-owned companies and the administrations, they are all pointed out with their respective responsibility in the program. They all have to implement this program in their business plans to show how will they contribute to fulfill the targets in the program. And appointed controllers will then follow up and analyze the progress towards the targets annually and report it to the City Council. The Climate Action Plan, it's a more concrete document with the calculated effects of actions. But as in the Environment Program, responsible bodies are pointed out and their work with the actions is also followed up annually and reported to the City Council. And both these documents are adopted by the City Council. The Climate Action Plan also includes a climate budget of 19 million tons that has to be cut down to zero before 2040. If you just look at the emissions that build up the short-term target, that is to get down to 1.5 tons per capita in 2023. These emissions consist of emissions from heating and cooling the city, the geographical city, the use of electricity and gas, and all the transports within the city boundaries. And here, if you look at the dark blue part of the diagram, you can see the development from heating the city Today we have a reduction of about 70%. This summer, the final coal-fired heat and power plant was shut down. And the challenge now is to get the plastics out from the waste incineration. Otherwise, you can say that this system is fossil-free, except for the plastics. The great challenge, that is the transport sector, and we have it in all cities, I say. And we can see a reduction here from 1990 to about 10% or a little bit more, even though we have 30% renewable in the fuels in Stockholm. So this is a real challenge for the future. And if we look at the future, we were talking, heard Peter about negative emissions, and I fully agree, it's very important. And actually carbon capture and storage is a proven technology, and it's no rocket science to capture the CO2 emissions and pressurize it, liquefy it, and pump it down in the earth. And promising tests have now been carried out on the heat and power plant on this picture. It's just 4-year-old. And also tests in Oslo. And now it's more about to fine-tune the technical parts of the system. The potential of this heat and power plant that you see here down at the bottom is an annual capture of about 800,000 tons of biogene CO2. It's fueled with the residues from forestry like tops and branches and bark from tree. And it should be then stored in new aquifers under the Northern Sea. That is not an aquifers in current use for oil or abandoned oil field. It's new fields to be stored in. But there are still some question marks, and that is the business model. Who will carry the costs? 800,000 tons, that's about 80 million euros per year. And someone has to take these costs. Maybe it should be an implementation of negative emissions in the European trading system, or maybe national support, or maybe the customers, or some of the customers, or a combination. But this question mark has to be straightened out. That's the main challenge for this technology now. So with a successful introduction of BECCS on this plant, or also other plants in the system we have here in Stockholm, we can see the possibility to become a climate positive city in a relative near future by second half of the 20s. But one should also remember it's important that this does not replace the work we have to work with to cut the fossil emissions, the 90 million tons of CO2, fossil CO2 that we have in our climate budget. So we have to work with both negative emissions and to cut the emissions, fossil fuel emissions. Thank you for the attention.
Thank you very much, Jonas. And then we end up this first turn by Brian. Is he still with us?
Thank you. Thank you, Ingo. And I'm just trying to share my screen. If Jonas can stop sharing, then I should have.
Yeah, I'm trying to find the.
Stop sharing is on the
stop
top.
it on top of the Zoom monitor. There you can enter your.
Oh, there, thank you. I thought it was at the bottom. Now.
Yeah.
Sorry.
You, Ingo, in the interest of time, I will try and keep my presentation rather short.
Okay, thank you.
And You heard a lot of the elements maybe in my keynote earlier today. I believe we have to take this extremely seriously. Cities are very, very important in the transition. 8 years ago, I created a new master program called Sustainable Cities, where we have a focus on what is the role of cities in fighting climate change and creating a sustainable development in accordance to the UN goals. We need to consider to change the whole way we talk about this. I have not listed all the publications that we have done. We have done many, many case studies of cities, and we have done many case studies of different kind of technologies. I would say one of the points that we need to understand is that in a city, we need to trust our infrastructure, and we need to trust the changes that we're doing. And this is really crucial to have the public acceptance and businesses acceptance of the changes that we're doing. So when we talk business models, maybe the business model is that they have to be part owners of this, and they have to be able to participate in a way where the costs are not driven up. You're not able to choose another electricity supplier or another electricity line. You're not able to choose, if you get district heating, you're not able to choose another district heating company. If you have transport systems in your city, that's a public entity that you need to trust that the costs are low enough. So it's really important to have a citizen-driven, a citizen ownership as part of this transition. The map you see here is a part of Denmark, actually a part where I'm from. And you can see the blue ones, that's where we have district heating, and the yellow ones is where we have natural gas. What you cannot see is that houses have been insulated. And I think one of the most important things a city can do is to have low energy consumption, and you can do that with insulating the houses. If we go to the bigger cities as well, we can have new transport systems, and I think it's very crucial that we try to build the infrastructure that we need in an efficient way. Every time we talk about expanding road-based transport in cities, we are also expanding or we're also reducing our chances of meeting the climate targets. We need to increase our mobility in other ways. And this is really, really important. And if we do that, we will also have more livable cities. We will have more pleasant cities. There's a misconception about climate neutral cities or net zero emission cities. This is a part of the past, and we need to move beyond this. And I think I'm not sure, I'm not completely aligned with all the previous presenters on this, I'm afraid. I think if we talk about climate neutral cities, what happens is that then you start to compensate for your transport oil consumption or your industrial coal and oil consumption. And you just imagine, now I don't have a slide on that today, but just in your head imagine that all cities are doing that across your own country or in Europe or in South America and North America. What happens to that electricity and that PV? Well, what happens is we can't use it, and it's too expensive, and we're still left over with oil and fossil fuel consumption elsewhere. What happens if we build new houses that are plus energy houses? We leave the rest of the houses on their own, which is probably 90 or 95% of the future houses. A future house that is a plus energy producer has an expensive way of producing renewable energy that is only fit for rich people. It's a limousine solution that I believe is not suitable for society as a whole. For society as a whole, we need things to be affordable and efficient. And a passive house or a plus energy single house is not a part of the broader solution. It is a small part of the puzzle that, if we're lucky, it doesn't hinder that we do all of the other right things. So I believe we need to have targets of 100% renewable energy systems for cities, and we have done quite a lot of cases studying how that should be done. And this requires that we consider the flexibility of our system. It requires we consider how electricity interacts with district heating. There's a huge potential for that. It requires that we insulate our houses and that we have electrified our transport system. And for sure, a city is not an entity that lives on its own. A city lives together with the suburban areas where we should have wind power. I see a lot of cities where I travel around with symbols of PV, where you are then in the city proud of a small PV plant that you can see from the street. This is a greenwash because it will not cover any part of the city's energy demand. It's something for show. It is not for real. For real things are large wind turbines in the suburban areas or in the urban, in the rural areas, sorry. Real PVs are those that are on large roofs that you cannot see in industrial areas. Real efficient cities are those where you cannot see that the houses are insulated or see the district heating pipes. Real cities are those where you can hear your neighbor because there's not a lot of car traffic or road traffic. That's a real sustainable city. So we need to consider that a city cannot only contribute with surplus renewables. A city has to contribute with flexible consumption of renewables. Otherwise, we're not going to be able to meet the targets. I would also like to comment on these things about CO2 reduction costs. And we saw one slide earlier here from Jonas, and it was indirectly mentioned also elsewhere. All of the things that I talked about, or that's not all of it, but 80% of the things I talked about in my keynote for the 70% reduction target in Denmark, and all of the things that I have mentioned here, are fully technically viable options off the shelf with not a CO2 reduction cost, but a CO2 reduction benefit. So we can talk about CCS, we can talk about this, but while we're talking about this, we can have concrete savings if we spend that money elsewhere. And I think we need to really consider that we should make the full transition. And if we make the full transition, we will discover that we can save money while reducing the CO2 emissions instead of having CO2 reduction costs. That concludes my little introduction here. Thank you, Ingo.
Okay, thank you very much, Brian, and thank you very much to all the panelists. At the moment, there's not a single question in the Q&A part, so that leaves me the rest of the 45 minutes to ask questions. Thank you very much. Or maybe you will start to ask your questions soon. I really thank you for all those expert views. We have learned a lot of technologies that can help. We have seen quite many good examples of buildings in different cities. We have seen a lot of plans and on which degree and which percentage cities want to become climate neutral. But to me, it's not enough. I really would like your expert opinions for my own work here in my city in Cologne. And I'm sure a lot of the participants here in the audience also would like to get ideas they can bring to their cities. And I would get a bit of your ideas. What can we really do as city authorities, or how can we bring city authorities going towards climate neutrality? The question is because I think city authorities do not own the city. There are, I think, thousands, hundreds of thousands, or in some examples, even millions of owners of the buildings of a city, of the cars of the city. And we have free electricity markets where the citizens can and the companies can buy their electricity where they want. So what is really in the power of city authorities where they can say, yes, we go there, and how can we start that process to go there? Anyone who wants to speak first can get the microphone.
Yeah, Ingo, it's Peter here. I think we probably should use this panel to just do a switch, just replace that word carbon neutrality or climate neutrality with positive climate action and climate negative action. I see in the quick poll that's on our screens, the question, can cities become climate neutral and do not rely on from what they might supplied from rural areas? That's a difficult question because there are two false assumptions in there. Climate neutrality is not a sustainable goal. It's got to be climate reduction targets. And cities, we know from the feasibility study done for Berlin about 8 years ago, that the cities can supply their own energies. In fact, Berlin was shown to be able to supply the rural areas around Berlin with the right measures, combination of renewable heat and renewable electricity efficiency measures, a lot of efficiency measures. And so there is a common assumption that neutrality is a good thing to aim at, but I must say I agree with Brian, it's not a good thing to aim at because it keeps people in a kind of an illusion that that's a thing that can be achieved without losing the climate destabilization battle. And as regards to Cologne, I think Cologne can learn from other German cities, not what they do, but what they say they could do. Berlin's feasibility study is a fantastic piece of work by Bernd Hirschl and others, but it hasn't been implemented. But it shows in a very pragmatic way and cost-efficient way that the 100% renewable target is not out of the imagination, and that it can go beyond 100%, even a big city like Berlin, and it can supply its rural areas. Thank you.
Yes, that's great. That is also my way of engineer thinking. I know what can be done technically to make a city maybe close to climate neutrality. And also when Berlin can do that with its surrounding areas. But how can we go for that? What is the real decisions? Anybody else in the panel who can help me for that?
Jonas, I must just say that I agree with Peter and Brian here. It's much more about cutting emissions, get them down as soon as possible. Like we're testing now with biogene emissions, can we store it under the sea? The most important is to cut emissions, not talking about climate neutrality and different ways of compensation. Then I think if you look at the transport sector, we will need electrification, but that will not be enough. We will need biofuels as well. And I think what will be coming up more and more is fuel cells and hydrogen. Maybe hydrogen that can be stored from solar production. If we look at the Plus House here in Stockholm, for example, yes, it can be a Plus House on an annual basis, but it produces electricity with PVs during the summertime. But it needs district heating supply in the wintertime when it's very dark up here in Stockholm.
If I could intervene, Ingo?
Sure, yes.
This is Brian from Aalborg University here. I think one of the most important things is to actually create a vision and to show what a viable vision is. So I think you have a role here, Ingo, to start that. And I would happily support you with our system analysis tool to do so, and also our experience with working with Danish cities. But of course, that is not enough. You need to involve the stakeholders. And I'm pretty sure that there are different kinds of stakeholders in Cologne that could be interested in this. The models, and I'm sure perhaps Şiir knows more about this globally than I do, but I see that there are different models for doing it. There is a civil society model where you see companies and citizens actually driving a lot of the changes independently of the public entities. But I would say sort of 90% of the cases that I know have some involvement of a city council of some sort. And this is also where, of course, you see the organizations like Energy Cities and C40 are also supporting and creating knowledge that can be replicated in different cities. But I think a way to start, if the city does not start themselves, is simply to try and illuminate what the current status is and where we could move if we wanted to. And the best, of course, way to create that is that you don't do it on your own, but that you find some key stakeholders that you involve in a process where they feel that they have an ownership for that kind of future that you could imagine for Cologne. And as mentioned, I'm happily supporting you in that endeavor.
Thank you very much. Şiir, you want also to answer?
I would like to intervene, yes. Ingo, actually, you had a very inspiring presentation several years ago where you presented your solutions for Cologne. And in that presentation, you emphasized the demand response, all the flexibility, and also using the urban infrastructure for using the excess renewable electricity in the urban infrastructure as power to heat and different flexibility options. And I know that from Peter's presentation, he emphasized Hamburg. Also, Hamburg is, in addition to the energy bunker, also using the flexibility in the district heating, and also Dresden from Germany. They're using the surplus electricity from renewables into power to heat for the district heating system to increase the renewable energy share. And there are so many options that urban areas can use, the existing options, to integrate such options into their systems. And it's just a matter of integrating this planning approach, like also the city of Stockholm. They're seeing where is the waste heat that can be integrated into the district heating system. And it is just about using all the synergies across all the urban sectors and using that in a way that addresses the available opportunities that are available at the city level, and also taking into consideration the broader national or targets. Putting the targets, I agree that putting a simple target for climate neutrality is largely insufficient. And a lot of cities, sometimes they put these targets without knowing how to reach there. And it's about aligning that governance framework, that governance departments. Urban planning is not enough because sometimes the urban planning is not looking into the energy planning, how we can use the density of urban areas for making more efficient urban infrastructure. And cities, they also have the power to implement the policies. So they can implement policies and incentives that can guide their citizens into using or motivating them to directing their attention to more efficient options. So they have the power, they have the regulatory power. They can zone areas, create the rules, and while doing all of this and using their ability to go beyond. So maybe they need to focus on reaching climate neutrality earlier, so then they can go into the positive climate status, using also nature-based solutions, the blue-green infrastructure for sequestrating cities, the regenerative cities. And I think they have a lot of opportunities. It's just about matching the available options with what they can create, what they can capture with the synergies between the sectors and the urban areas, with the policies.
Thank you very much, Şiir. And now I would like to involve also the audience. And when we can give the micro to Viola. Hello, Viola. Haven't seen you a long time. And also I would like to ask Maya and Nevin to raise their blue hands. Ah, yes, Nevin just did. Yes, then you will be next. Viola.
Hello, can you hear me?
Yes, we can hear you.
Yeah, it's a long time no see. I really wanted to be there in person. My question was, what can we do about the historic buildings that cannot be renovated or insulated in a straightforward manner? We don't want to demolish them, but we have really strict regulations on what the facade should look like. You were talking about energy or climate neutrality for the city, but we have to acknowledge that there are buildings that are not capable of achieving that status because of their historic building types. And those are actually not just single buildings, but whole districts in a European city for sure.
Yes, if I may take that. The beauty of being in a city is that we are in a community of users and producers, potential producers of electricity and thermal energy, and also energy for transport, and also the capability of absorbing carbon, either in building materials or in other ways. And so if you have a building that's historical or just can't be transformed because of financial reasons or some other of the many reasons that keep buildings largely in the sort of 2 maximum 3% of renewal rate, then the others have to step in. The new ones have to be over or compensating. So if you build a new building, it has to produce more than 100% of its own energy consumption and share it with the others. And that's the wonderful future of distributed renewable energy and thermal resources in cities, where we have a very tight and compact framework, and with public utilities moving that direction and the community participation involved and the sharing of the prosperity opportunities in that, we have a very different energy sharing model than we have now. And so no city will be left behind in this vision, and no building in any city must be or has to be left behind in this way.
May I comment a little bit on that as well?
Yes, please.
Yeah. I think we have a lot of these buildings in Stockholm, brick buildings that cannot be insulated further. But if you look into digitalization and artificial intelligence, we can use these tools very, very much today to optimize energy performance of buildings and maybe save 10–20% of the energy used in the building. And that is becoming a more and more cost-effective way to do the energy efficiency work than refurbishment work. And we have a company here in Stockholm responsible for the school buildings, and they have come very, very far in this work, where they can make a digital twin and have it as a test lab and bring it back to the real building and optimize the system, the ventilation system, and so forth. So I think it's a very big potential there as well.
Thank you.
So thank you very much. Then I would like to pass the micro to Maya.
Hello, everyone. I just had one remark. I said I like the idea of owning a city. That would fit very good to Cologne because we have a very big ego anyway. So why not put Cologne on Wall Street? And people that are interested could buy a share of it. Maybe I would also buy a part of San Francisco or Edinburgh. That would be interesting.
Was rather a comment or a question?
A comment.
Okay. Thank you very much. Yes. You really want to transfer it to the United States, our city?
Well, the question is not entirely off base. If you add energy to it, I think citizens, but also others, could own parts of the energy system, invest in an energy future in urban areas that they can share benefits in. whether in direct receipt of renewable energy from the urban energy infrastructure, or from returns. Energy systems are also businesses, and they need capital. And if we can involve citizen capital, cloud finance, and also perhaps even international investment in particularly exciting energy strategies like the city of Cologne's future strategy, informed by Ingo and Brian and others, then why not open it up to some opportunities for investors from near and far?
Okay, thank you. And then we switch next question to Neven.
Hi. Well, if the future energy supply will mostly be variable renewables, wind and solar, then we will need quite a lot of demand response, and cities sound to be like very good for that, because they have significant heating demand and also mobility demand, which could be moved in time for a few hours without problem. So why don't we design cities as big storages of heat and mobility? When I'm saying storage of heat, obviously district heating looks like a better solution for dense areas. Because if you want to build a heat storage in individual house, it takes quite big space, maybe 4 cubic meters. And also charging electric cars doesn't make sense to do them on fast chargers. We need to have slow chargers, but smart slow chargers everywhere, on every parking place, at work and at home. And this could actually allow for doubling or even tripling of variable renewables penetration. Peter has already answered a bit on that, but I would like to see more of your points of view.
Thank you, Neven, very much for the question. And I agree with everything that has been mentioned, that cities, they need to use that demand side flexibility to participate in 100% renewable energy scenarios in every way possible. And in addition to the heating sector, the transport sector, electric vehicles, electric public transport, and using all of this, they also have the water system that they can do this flexibility. The waterworks, the electric pumps in the waterworks, they can be used in times like in the elevated water tanks for drinking water. So they have numerous opportunities in the heating sector. As I mentioned, the power to heat flexibility, using the excess renewables into the urban infrastructure. This is a perfect solution for cities to participate in 100% renewable energy scenarios. And also using the water infrastructure as much as possible, also either with the storage, the water storage, or flexibility within the water infrastructure. But cities are perfect for what you have just described, also on the demand side.
Thank you, Şiir. If nobody else wants to answer here, I would like to give the micro to Goran Grajcek. He is in opposition, wants to go in opposition with Brian, but yes, he has the micro. You can ask a question.
Okay, hello, can you hear me?
Yes, very well.
Okay, so I just would like to ask Brian, because I do not totally agree with his position, which was today very strong related to this photovoltaics on the rooftops and in the smaller buildings, because as I wrote in my explanation, I think the people should be allowed to grow their own vegetable in their own gardens. So no matter what price of this vegetable be, but of course then we have a situation going with these vegetables to the marketplace, etc. Maybe it's not currently regulated by the law or our taxes, but I think in 21st century we can really regulate this because of digitalization and all the stuff that is related to it. So I just also saw some buildings in Aalborg, which is quite familiar to Brian, new buildings or renovated buildings that have quite well integrated photovoltaics in facade, etc. So it's they look for me nice, but I think it's also in some way effective. So if we have cheap passive houses, which can be done, you know, the price per square meter can be really in the range of some normal construction if it is operated properly. So I think these solutions also should be promoted. So I don't know why it's now the Brian was quite against it, and can he explain this his point of view of these smaller solutions, and if he can comment my comment, okay.
That's over to me, I think, Ingo. So thank you, Goran, for that question. I've actually investigated photovoltaics quite extensively, and it was a frustrating process for me to do, because I realized some of the things that I mentioned in my presentation. And I don't mind that you and other researchers are dealing with small scale PV on a single house. And I don't mind that people are developing building integrated PV. But I can just see from the numbers and from our analysis, using also projections of what could happen to these prices of 5 kilowatt PV systems or building integrated PV systems that are almost as expensive as normal PV systems. I can just see that they're not doing a lot of good. So I'm not going to be a big promoter of that. I'm going to be a big promoter of large roofs, because when I realized that that is the case, that they will also be much more expensive, these PV, not only in 10 years, but also in 20 and 30 years, they will be more expensive than larger PV systems and more expensive than wind. When I realized that, then I also got frustrated, because I understand your feeling that you want to grow things in your own garden, and you have the right to do that. So we need to give people another, let's say, tool, another thing to be part of. And I then sat down with some of our land surveying people, and we made some GIS analysis that we have done on heating for Europe, but we did it then for PV in Denmark. And we found out that we have about 4 or 5 times the amount of roofs needed on roofs larger than 500 square meters. I said 4 or 5 times the amount needed. And those kind of systems, I as a citizen can be a co-owner of. And the beauty of such systems is that they're not placed on a field far from a city, which is, of course, when you look at it, cheaper. They are placed next to the city or on top of the city, where also the electricity consumption is and where the electricity grid is. They're not placed in a far corner of the country where the electricity grid has to be expanded because the peaks of a PV is extremely large and requires a heavy expansion of the distribution grid. So I believe that that is the viable solution. And I believe that if you want to do PV any good, then we need to direct the finances to those bigger roofs instead of having these small feel-good systems where you can cover 20% of that individual house demand with the cost per kilowatt hour that is much, much larger, maybe 3 times larger than an onshore wind power park, or 5 times larger. So I think it's a hard debate. It's really hard, but I think we have to get used to these debates. We have to get used to saying to each other, it is not everything that is green that is good. And even though this is green, it's not green enough. We need to make something that is even better, that is even smarter, because it is not enough that those people that can afford to build a really small, expensive PV on the roof and have the carpenter walk up to put in 5 kilowatts of effect PV. That is not enough. We need further developments in order to achieve a full transition.
Thank you, Brian. I really appreciate your contribution to this discussion, and I'm not, as I said, totally against this, but thank you.
But I think also Peter wanted to respond to the same issue, that's right?
Yes, actually I wanted to respond to Brian and congratulate Goran on this important question. I don't think, Brian, you quite grasp both the potential and the challenge here. First of all, it's not a question of either or, we need everything. And we need to upscale PV and all kinds of other renewable sources as quickly as possible. And if individual small people and individual investors and renters, tenants on balconies want to do it, we shouldn't keep them from doing it. You sound a bit like there is a central finance source that flows to everyone, like the old energy model. This is a bottom-up revolution, and we had it in Germany with the feed-in tariff. Today we have a situation where a lot of people have PV on their roofs, and the feed-in tariff is being reduced and perhaps even ended. So the question is, should we dismount these PV panels and throw them in the trash because we don't get the income anymore? Well, the answer is no, because the answer is self-consumption. If the PV on the roof can eliminate your own electricity import, because the electricity you buy from the grid is maybe 20 cents a kilowatt hours, the one you produce yourself may be free, or maybe 2 cents a kilowatt hour. That's a much better deal. And so the renewables change. The renewables revolution means that you actually moving that opportunity, economic opportunity, to individual owners, investors, distributing it in a democratic way, rather than focusing on the supply on faraway corporations which own large wind farms, whether they're onshore or offshore. But I know you're also arguing for large roofs, and nobody can argue against that. If IKEA or others can do that, they should do it, and they should share it with other people. They should invite cooperatives, they should invite citizen investors to share in that opportunity. But why argue against my grandmother putting PV on their balcony if she wants to save some electricity? Because what she can in fact save from the utility is worth a lot more than she can possibly generate if she exports it.
So thank you very much. While there is a new question from someone, I think it's not a real name, but something shortened KILKIŞ, until he is or she is raising his or her hand, I think now it's done. So I give the word to KILKIŞ. You need to unmute your micro. In case you try to speak, we cannot hear you as your micro is still muted. On the complete left lower button of the Zoom screen, you'll find the micro.
During this time, Ingo, maybe you would like to share the results of the polls that are ongoing.
I could do so. Unfortunately, I do not see the results of the polls anymore. In order that I see your faces, I already clicked them away. But the first question in the poll had been that the question whether cities can become climate neutral or not. I don't remember the names, maybe Marco or Eva can tell us that, but the majority said no, they are not able to do so. And in the second one, and that was where I also would like to take the next question to the panel, that was the question, which sector cities can do most for that target, whether it's electricity, heating, or transport. There the majority said it's transport. And maybe that is what my next question want to be to the panel. I have heard several times in the panel and seen also in some presentations on our video platform that it's always the transport is the biggest problem. But isn't that exactly the one a city authority can do most, because they do not own our houses, they not sell electricity, but they own the streets, the parking slots, the parking places. Is not transport the most easy thing where cities can do action? Jonas.
Thank you. I wouldn't say that it is the easiest thing, but a lot can be done. And we need to reduce the transport work in the cities by cars. And of course, cities can build out the infrastructure with a better bike lane. We can have a dialogue with the citizens so they can use the bike lanes much more. We have had campaigns here in Stockholm with the citizens. They will get studded tires in the winter because we want more people to bike in the winter time. And then they also sign up to bike to work for 3 months, January, February, March, the worst months here. And when we follow up the results, we can see that the majority after that, they could leave the car back home and gone biking in the wintertime. So that was very positive results. We're also running a campaign with the business society where we make them compete to have the best workplaces for bikers. And then we have an annual event where they get a very nice prize and they can go on and compete year after year here. So that is one way to do a behavioral change that the cities can facilitate much more. The next one is fuels or the energy we use for the cars. We can make it much easier to charge the cars. We heard it here before. We can work with property owners so they have slow charging stations in their buildings, and we can have street charging in the cities as well. And then we can lobby our governments, or maybe at EU, to make it possible to use more renewable fuels. We can sort out waste in a better way. We have a target in Stockholm to sort out bio-waste to 70% and produce biogas, and the bottom rest from the digestion will be used in the farmland. So yes, there's a lot to do from the city side.
Okay, let's try it once more with KILKIŞ. I think he is or she is now online.
Yes, I am here. Can you hear me?
Yes, we can hear you.
All regards for all of you, for panelists. I have a very short question. I think work to increase and to be easily integration of renewable energy sources. Especially, I think that it's so to photovoltaic. I think today many regulatory framework which achieve possibility to build photovoltaic. If you compare with concentrated enough regulatory framework adopted today in EU. Can you comment that, please?
Did everybody get the question? Because there was sometimes the noise was interrupted, the sound was interrupted.
Can you repeat the question, Ingo?
No, I can't because I didn't got it too. Could you try to make it short once more?
Very short. Can you comment a regulatory framework today which adopted, if you compare photovoltaic and concentrated solar power sources of electricity? I think today we have not enough regulatory to possible to integrate solar power is photovoltaic.
I think it is very hard to understand the second part of the question again when it gone, but it was something, if somebody wants to comment on regulatory frameworks for both solar PV and solar concentrated power.
Well, I can.
I think for concentrated power, we have not enough regulatory framework today.
We've got too much regulatory framework. We need less regulatory framework. This is what's killing the renewable transformation, is too much regulations that are not geared towards the rapid expansion. In Germany, we have so much regulation in constricting not just the application of PV or other renewables, but the sharing of that with others. It's very expensive to buy renewable energy. It's very hard to sell it. We get very little money for it. There are regulatory controls that determine a price differential of 1 to 10 between your own generation and what you have to buy from the grid. So you're actually punished for doing the right thing. And it's all regulation. It's got nothing to do with the market. I'm not a free market liberalist, but here in this case, I think we have too many regulations designed to slow down the transformation of our energy system. And I can try to break up my voice to answer the bits of pieces that we didn't understand in a similar. I end here. Thank you very much.
Thank you.
You wanted to add something, Brian? Or is it enough?
Well, I would actually like to comment on this PV issue again. So the thing is, all the countries where you have already installed small PV on the roofs, that is fine. That is not something that we should do anything regarding. But we have to realize that a feed-in tariff has to stop at some point. And we have to direct feed-in tariffs to those technologies that are needing them. And also we have to realize that behind the meter schemes, where we're not paying for a grid that we need when the PV is not producing, is essentially putting those costs onto other citizens that most likely cannot afford to have a PV on the roof. So we can talk of, there can be regulations, of course, that are wrong. I don't disagree to that. We can also discuss whether we should pay VAT of the grid tariff. But if we're behind the meter and we're not paying what we should, then I think we're having a problem, because we need to do the full transition. And of course, we need the grid operators to behave in a way that animates the transition in a sensible way. But I think that we cannot in general say that all regulations are bad.
Well, I think there's no we here. And I think one of the problems is that PV came so late in the evolution of buildings and the evolution of cities that we don't think of it as part of the buildings. If we thought of PV as being part of the buildings and part of the urban infrastructure, we would just require a PV roof, just like we require a roof today. We don't accept buildings without roofs because it will rain into the top floor and it will drip down to the basement. So we have roofs, and why don't we have roofs that also supply the energy of that building below? It's only the sort of a tradition that comes from the 19th, 18th, 16th, 17th century, which keeps us from doing that. There should be regulatory requirement that every building has to have enough electricity, renewable electricity supplied to supply its own sources. And only if that's not possible for some reason, it should move somewhere else. The PV cost will disappear in the marginal cost of the development construction cost of a building. It will just disappear. And it's just a madness of our society. We don't teach our students, we don't require our architects, we don't require the investors to build buildings with that missing piece, which is renewable energy generation and management. It's part of the building infrastructure. It's just beyond me why in the 21st century we talk about it as if it is something we screw onto the roof and we have to worry about how to finance. It finances itself, Brian.
But I guess connected to that, then those requirements, we should stop grid connecting those houses.
Oh, we need both. I think you can.
Okay, so then they need to pay for the grid though, right?
Well, they do pay for the grid.
What if it's behind the meter?
It's not behind the meter. It can be largely behind the meter, but when you have a surplus, and we just answered the question that somebody had: what do you do with historical buildings? What do you do with all the 98% of buildings that will be there for the next 10 years? They have to be supplied by their neighbors, and for that we need the grid. And so the grid is a public good, or the grid can be a private good or shared good. But the grid is important. That's the nervous infrastructure. But in the grid, you've got organs that supply themselves. And you don't tell your stomach or your heart when to beat. It does it by itself. And so its own program and supply system. And if a building can, in fact, supply the neighborhood when it doesn't need the electricity, let it do it. Because the cities change very slowly. And if we want to change tomorrow, we have to allow every little investor, every little building that applies for a building in permit this week to do the right thing and not say, well, let's wait for Brian's utopia when we have giant PV roofs that cover everything and everyone's supply.
I think we do not get that a last sentence from Jonas to that topic.
Okay. I think we shouldn't just think about PVs as that is only electrical production. I think it's very important if you have district heating systems that we also have, of course, with biofuel, and that we also have combined heat and power production for the cities in the district heating system, not only the heat production.
Okay, thank you very much to all of the panelists, but I do not like to end like that. I would like that maybe we finish our panel, that every panelist can give one sentence as a conclusion. And we are talking in English language. In German language, we can build sentences that will last for 5 minutes. But please, we use the English language, and at the first full stop, we end our comments. So I would like for the final statement, I now go into order how I see the participants on my screen. So I would like to start with Manuel. You have a final sentence.
Hi, thank you very much, Ingo. I think the energy transition is very complex because it depends the context. If you have resource, you can cover the consumption with the renewable energy. But if you don't have resource, you have a lot of problems. I think the density cities have a lot of problems in order to create the energy transition. But it's important. I think it's important development all the energy transition in order to cover all the consumptions. And so this is my point of view, but because I am from Ecuador, in Ecuador is totally different. In Ecuador have a lot of resource, hydraulic resource, hydraulic dams, and now eolic and solar, and the gaps, the generation gaps is very little, and in Ecuador we can accumulate the renewable energies, but it's different in Europe, and because you have different seasons, etc.
Manuel, that's worth 35 sentences just now.
Yeah,
you were given
Monica,
one.
thank you, Manuel. Monica, you said the last sentence.
Yes, I would like just to put, we have been talking a lot about the complexities of urban energy systems. And yes, we have been talking about different sectors in which we could promote renewable energy technologies, in which we can promote energy efficiency. So I would like just to point out that there is still a very strong gap between the availability of solutions and of energy system analysis tools, and the capabilities of local public authorities to make decisions with a comprehensive approach and looking at a medium long-term time horizon. And I mean, this is maybe not so true for big cities which take part in several projects, but for sure this is a strong problem for smaller cities, especially in Southern Europe. So I would say that it is necessary that the academia and the scientific part works more and more in collaboration with public authorities, because otherwise we talk about carbon neutrality and we talk about very ambitious targets, and then when we look at decision makers at local level, they still don't know which data, I mean, how much electricity they do use in their city. And so I really would encourage a really strong cooperation between the scientific world and the local stakeholders and local public authorities.
Thank you, Monica. Rodney, I admire your capabilities to directly come to the point.
Most of the debate tonight has been, I believe, around this sort of centralized and decentralized and small scale, medium scale, large and diverse energy sources. And I sort of agree with Brian a little bit about the small scale systems, particularly the small scale, so power wall systems that supply you know, a part of the demand of the house, but still drawing on the grid. These can be problematic, I believe, long term for the long run cost and viability of these systems going forward. So I think we really should think about these medium scale decentralized systems and be promoting those over for very highly distributed small scale systems that come with a lot of risks and being owned and governed by individuals and have high risk of failure as well. So I think that's the main points I'm getting from tonight, is that usual debate about you know, level of centralization and decentralization to manage that diversity and complexity of the system.
Thank you. And Şiir.
Thank you very much. I think that one sentence is urban areas are places where integration across energy, water, environment systems are providing a lot of opportunities. And I think we've tried to emphasize that as much as possible. And why is this effective? Because we are actually reaching the point of tipping points in the global climate, and we need the most effective solutions as possible. And urban areas are where this action can take place. I would like to put the sentence stop there, but also answer an ongoing question. What should be borders for city planning, city or region by Goran Krajic? And I think this is also including the urban-rural linkages, because as an example, going from Sydney, in the Sydney Decentralized Energy Master Plan, they're also including these urban-rural linkages, for example, where to get not only biowaste from within the urban area, but surrounding areas. This is very important. And looking out to 2100, not only do we have the challenge of our existing cities, but also we have the challenge of new cities that are still in the planning, that are still in the planning phase. And each city, new city that is built, it is an area that are reducing the carbon sinks. So also this planning needs to include how can we limit urban growth, how can urban areas be more compact, how we can densify existing urban areas. So the urban planning is very important, but with this integrated view, also including the urban-rural linkages.
Thank you, and Takaaki.
Thank you, everyone. Today, I really understand the importance of the sector coupling, especially the electricity and heat. But in Japan, there are almost no district heating system, and heat sector, even the Tokyo, there are quite large heat density in Tokyo. So we have to consider the how to design the sector coupling in Japan is very important. And I'm very sorry, I often left my seat. That's all, thank you.
Okay, thank you. The next is Peter.
Thank you, Ingo, and thank you, everyone. It's a fantastic session. And I'd like to just end with a 4-word sentence, which goes back to the theme of the conference, the climate neutrality for cities, and pointing out how important the mental frameworks are we have. It really is now time to go beyond neutral and to realize that it's for us all to up to us to change that term and to go beyond neutral now.
And Jonas.
Okay, thank you very much for this session. I say that cities really can make a change, not only for electricity production, and we are all very often forerunners as well. And priority 1, 2, and 3, I would say, is political commitment. From this commitment, we can take concrete actions, and from these actions, we can share good and less good examples for dissemination and the learning process.
Thank you. And then the final one, once more, is Brian.
How enjoyable to be able to finish this up. Then I cannot have any comments from the others about what I say. No, thank you for the nice debate. I think it was most enjoyable. My words, I would like to repeat: go beyond climate neutrality and net zero emission cities, go beyond net zero emission districts, and go beyond net zero emission buildings. And when you start to look at your city, go beyond your own little sphere. 1/3 of the electricity demand is for households, and 1/3 of the overall energy demand is electricity. So if you only look at your daily life, when you look at the world, you're really not solving the world's problems. So we need to look beyond, and we need to have the full picture before we can understand how we do a feasible transition.
Okay, thank you very much to all of the panelists once more. Now we have time for coffee break. Everybody who wants to come to my office gets coffee for free. So I wish you to have, when you are in Europe, a nice afternoon. Good night to Takaaki, And in South America, you have the most part of the day in front of you. And for sure, Rodney, also good night. Bye-bye.
Bye-bye.
Thank you.
Thank you very much.
Bye-bye. Thank you. Bye.
Bye.